Department of Energy, Fundamentals, Engineering, Symbology, Printing and Drawings, Module 4, Electronic Diagrams and Schematics. Table of Contents, List of Figures, List of Tables, Reference Objectives, Electronic Diagrams, Schematics, Introduction, Electronic Schematic Drawing, Symbology, Example of Electronic Schematic Drawing, Reading Electronic Prints and Diagrams of Schematics, Block Drawing, Symbology, Example of Block Diagrams, Summary, Example 1 and 2 in Summary. List of figures, electronic symbols continued, example electronic schematic diagram, comparison of electronic schematic diagram and its pictorial layout, transformer polarity markings, schematic showing power supply connections, NPN transistor conducting, NPN transistor non-conducting, PNP transistor diode, bistable symbols, example blocks, example block diagrams, example the combined drawing, pipe instrument, drawings, electrical single line, electrical block diagram. Examples of combination of diagrams, electrical single line block diagram, figure 16, example 1, figure 17, example 2. List of tables, there are none. References, dimension tolerancing, graphic symbol, electrical diagrams, digital troubleshooting, engineering, drawing, design, handbook of logical circuits, logical design with integrated circuits, naval auxiliary machinery, reading schematic and symbols, standard graphic symbols, system summary with Westinghouse pressured water reactor, and valve selection handbook. Your terminal objective, give a block diagram for the print and schematic, identify the basic component symbol that is presented in the module, identify the symbols on engineering, electronic block diagrams, prints, and schematics for the following components. A, fixed resistor, V, variable resistor, C, tap resistor, D, fixed capacitor, E, variable capacitor, E, F, the variable inductor, G, F is fixed inductor, G is variable inductor diode, for H, I for light emitting diode, J for ammeter, K for voltmeter, L for wattmeter, M for chassis ground, N for circuit ground, O for fuse, P for plug, Q for headset, R for light bulb, silicone to control rectifier, SCR, half-wave rectifier, full-wave rectifier, oscillator, W potentiometer, X rheostat, and Y antenna, Z amplifier, A PNP, and NP and N transistors, BB junction. State the purpose of the block diagram, electrical schematic diagram. Intentionally left blank. Alright, your electronical diagrams. The basic understanding of electronic diagram, electrical schematic, basic symbol conventions must be presented. Identify the symbols used in engineering, electronic block diagram, prints, and schematics for the following: fixed resistor, variable resistor, tap resistor, fixed capacitor, variable capacitor, fixed inductor, variable inductor, diode, light emitting diode, ammeter, voltmeter, wattmeter, chassis ground, circuit ground, fuse plug, headset, light bulb, silicone controlled rectifier, or SCR, half-wave bridge rectifier, full-wave rectifier, oscillator, potentiometer, rheostat, antenna, amplifier, PNP, and NMP, resistor, and BB junction. Alright, EO1-2, state the purpose of the block diagram and electrical schematic diagram. Alright, introduction. Electronic prints falls into two basic categories: electronic schematics and block diagrams. Electronic schematics represent the more detailed category of electronic drawings. They depict every component of the circuit, the components, and technical information such as its rating and how each of the component is wired into the circuit. The block diagrams are simplest type of the drawing. As the name implies, the block diagrams represent any part, component, and sometimes and system simple with the geometrical shape, with each block cable representing a single component such as a relay or other entire system. This is intended for the drawing, indicates the level of detail provided by each block. The chapter will review the basic symbols conventions used in both types of drawings. Electronic schematics, drawing symbols. Of all the different types of electronic drawings and the electronic schematics provided with the most detailed information about a circuit, the electronic component of the given circuit will be depicted. In most cases, the rating of the other applicable component information will be provided. This type of drawing provides the level of information needed to troubleshoot electronic circuits. Electronic schematics are more difficult type of drawing read, and because they require very high-level analysis on how to each of the electronic components is affected by the electronic current. The chapter reviews only the symbol commonly used for the depicting many components of the electronic system. Once mastered, the knowledge should be enable the reader to obtain functional understanding of the most electronic prints and schematic. Figure 1 and 2 illustrate the most common electronic symbols used on electronic schematics. Alright, figure 1 shows the resistant capacity of relays, which is a zaggedy line equals a resistor. A tapered resistor has a zaggedy line with, in the trough, there's lines drawing downwards. Variable resistor is a resistor with a ray at a diagonal shot through it. Rheostat is common with a resistor, but with an arrow touching on the last cap. The pentometer is an arrow on the middle cap. The fixed capacitor is a flat and curved union, and or flat and inverse flat union, perpendicular flat union. Recip variable capacitor, a flat and a curved union with a ray across it. Inductors are column little humps, and variable inductors little humps with a ray through it. A magnetic core shows a hump with two lines going through it. Solid solenoid or relay shows as a heart rate beat minute or a comb. The contact open is an open parallel lines. Closed is crossed out through the closed parallel lines. Your transformers are like wire winding. Your magnetic transfer and wire winding with parallel lines drawn through it. Linear voltage differential transformer shows a transformer split in half with a relay running from from the iron core from one of the columns of the transformer to the different one. The battery is basically parallel lines. Dash in the middle shows the different cells. The plug is like a plug. It looks like a plug. Female jack plug is a Y-ended fork, or fork in the road. A male jack plug is an arrow. A separable connectors are the double arrow line. Sound jack female is a circle on a square ride. Sound jack male is a looks like a circle with a spoon on a rectangle. A lamp is looks like a lining or a circle with four lines going at the ends of the where it would split, but not in the middle, or a double zero line with circled in this double zeros in a cylinder on each end. A bell is a square with an O. A buzzer is a square with a angle or relay on it. A speaker looks like a speaker. Headset looks like a headset. Microphone looks like a microphone. Antenna looks like a antenna. Circuit ground breaker is a perpendicular lining with lines drawn in a triangular form down. Chassis ground is like three ways into one. A conductor is a straight line. A crossing conductor is perpendicular or jumped over the perpendicular. Conductor junction shows a connection between the perpendicular lines or on the or extension lines. Alright, your components. A terminal board has circles with parallel lines running through a rectangular surface, or parallel lines running through a rectangular surface. Your PN transistor shows is basically a V shape on a T through a circle with an arrowhead going through the center, and NP transistor arrowhead going through the right through the outside center. The diode looks like a filled-in triangle with a line in front of it, or a circle with a filled-in triangle with a light in it. Light-emitting diode is a triangle with a slash and two rays, or a circle with a triangle with a slash with two rays. Linear diode is a Z shape with a triangle filled in. Rectifier triangle with a flat line. Rectifier with a full wave is a triangle filled in with a 1, or a what looks to be like a square, a diamond with different arrows running the different paths from positive to negative. Silicone controlled rectifier is a triangle that's not filled in with a line in it, also with a detachable spawn line on it. Amplifier is a triangle without a line, just a clear triangle. Switches is like a doorway, one like a gate, and fuse is a swirly semi-swirl line with or a triangle rectangular with two dashes and parallel small ends at the side. A position dock switch has three different connectors, and a gauge looks like it switches, and the relay is in between each of the connectors. A breaker is also shown as a concave relay. Push button normally closed, H perpendicular with the connectors are closed. Voltmeter meter is V with a circle. AM meter is A with a circle. Ohm meter is OHM with a circle. Watt meter is W. AC source or oscillator is an S with a circle in it. Your normally open close is a perpendicular over two connection points. Position push button to position 2 points over a normally closed push button. Your abbreviation and label V is for volt, A for A. Resistance shows the headphone looking like symbol or union symbology. Capacity for F for farads. Potentiometer with a POT kilo times 1000 or K. Mega times 10 to the 6 or M. Transistor O, capacitor Z, resistors R, inductors L, diode CR, milli, M, micro times 10 to the 6 is U shaped. Alright, example of electronic schematic diagrams. Electronic schematic diagrams used for each of the symbol time with the electronic circuit. No matter how small the schematic does not show the placement of scale, nearly function and flow for this actual working piece of electronic equipment can be determined in Figure 3 with example electronic diagrams. Figure 3 diagram shows your here's your transformer, here's your resistor 1, resistor 2, resistor 3, resistor 4, a breaker on this side, your amplifier going through what looks like a rectifier to rectifier to a capacitator. You have your PNP resistor, your 4 resistors, your diode, your capacitor, your volt and plus meter, volt plus and minus sign. It's a single line. Solenoid relay on the left side. The second kind of electronic diagram, the pictorial layout, is actually not as much as electronic schematic pictorial, how the electronic circuit actually looks. These drawings show actual layout components of the circuit board that is provided with the two-dimensional drawings, usually locking down from the top of the detailing components in either the location shown in Figure 4, the schematic of the circuit, and the same circuit is drawn in the pictorial layout form of the comparison. Normally the pictorial layout will be accompanied with the part list. Figure 4 shows a delta signal with a resistor, with resistors going in a circuit from the positive to negative on the one side of the diode. There's 6 different lines running from the 2 different deltas, 1 PN to 3 NP or PN resistors, an amp per single bulb light. Resistor, capacitor, diode, kilowatt, whatever what the spaces between those, contacts, and then B shows a printed circuit board diagram where they're labeled with abbreviations in different sizes. Reading an electronic diagram, electronic printed diagram schematic. To properly read and schematic, the reader must identify the condition for the components shown with the following: the advances that occur with the circuit functions with an electrical system. The relay contact shown is always to be energized with the condition. Modern electronic systems usually contain few and if any relay contacts. These normally play a minor role. Electronic schematics are more difficult than read electronic schematics, especially with the solid state of the devices are used with electronic software. Fundamental handbook discusses electronic schematic in detail knowledge of the working of these devices necessary to determine the current flow, and section with the basic will be covered to do assist the reading skill. The first observation dealing with the detailed electronic schematic and source of the polarity pole with generally power, it will be shown with the 2 ways, either the input transformer or as a numerical value. When the power is supplied with the transformer, the polarity marks will be added, and the determining current flow with the convention dot for the primary, secondary, indicating with the current for the primary and secondary, given with the instant time of the Figure 5 with the current at the top of the primary, out of the bottom of the secondary. Our figure 5 shows the transformer polarity markings. This shows the from the primary, it goes down through the polarity to the secondary, where the current flows through the transformer. Generally, the electric power source is indicated with the point where it enters the particular schematic. The values that are numerically polarity assigned at 15 volts or negative 15 volts. The marking usually at the top of the bottom schematic. Notice not always, but not always. For example, figure 6 shows a bottom on the top of the bottom of the circuit using two power sources and specified with the alternating current per power source and the voltage normally assumed in direct current. This shows your PNP rectifiers, your NMP rectifiers on this side of with a resistors going around them, and diode and a column relay. They're grounded at this diode, resistors, and these circles, and indicate pretty much these are dotted circles. I can't remember, but you have different grounds at the all through these resistors. You have different diodes going from the 15 volt current polarities. If any circle of the ground current must be established to create the current path ground, is usually depicted with the usable ground system that is shown previously. The direction of the current flow for the determined observing the polarity for the power supply. The polarities are shown with the current for the flow. The establishing ground must not always be shown with the power source located with the ground point established. Operating of the device can be determined. The most common semiconductor devices, the transistor and diode, they are made from the materials like silicone, germanium, have electrical properties of the intermediate between the conductors isolated. The semiconductors will be used one of the two variables, PNP or NMP. The transistors or the semiconductor, the designation indicates the direction of electronic flow moved through the device. The direction of the arrow indicates the type of the shown figure 2. However, the many different ways to install the transistor achieve different operational characteristics, too numerous to cover here. So, only most common basic figure configuration, the common emitter will be shown. Even though the transistor can multiply in junction with the P and N-type material, current flowing generally in the same direction. The conventional current flow is from positive to negative. Current will travel through the transistor. The most positive least positive in direction of the arrow on the emitter. The figure 7, the transistor have the power supply with the ground on the emitter, and if the input is also positive, the transistor will conduct. Or it shows the resistor going through a what looks like to be a PNP NMP transistor conduction from the positive to the base junction, while the power goes through the resistor and through the base junction while the input follows the line. Once it hits the power to the emitter, the current flow shows from positive to negative. If the input goes negative, the figure 8 conjunction device, because the input point of the base conjunction controls for a condition. Notice when the current flows, it does not direction arrow. There's no direction arrow. In a negative flowing, the power goes from the resistor to the input, and then from the base junction to the emitter, which looks like a ground emitter and no current flow. Figure 9 shows the PNP and transistor. The same rules apply, except for the time polarities. Power must be changed to allow the current flow. Your A conduction goes from the emitter to the base junction input with the current flow, and going from the input to the power through the resistor. Also, non-conducting input, base junction, emitter, and power, no current flow. Same rules apply for the transistor, hold true for the diodes. However, the diodes are simpler than transistors because they have only the conjunction conduct in one direction, indicate the figure 10. The diode symbol, like the transistor symbol, shows the direction of the conduction by the direction of the arrow, which is either from positive to negative. This shows the current flow from positive to negative in the conduction diode, and no current from the negative to the positive from the diode on the non-conducting. Although these simple rules will not always allow you to read electronic schematics, they will aid you in understanding some of the basic concepts. An item that may cause confusion with the reading of the electronic prints and schematics, the markings used to show bistable operation must be capable of bistable will indicate the box or circle shown in figure 11a with the lines in around with the bistable do not only mark the bistables but also indicate how they function. Your first basic bistable symbols are a bistable, which is a Z in a circle or rectangular convention denoting biostatus of the rectangular with a triangle. Trips of the decreasing signal, lever states, Z, horizontal Z, trips on an increasing, another Z facing the other way. Trips on a decreasing signal at one of the set points resets increase and the signal is in another setting. Is a box with a box Z or one ray going perpendicular through the center and one other ray going up horizontal and on the vertical, up vertical and down vertical. Trips on an increasing signal or the set point decreasing. There are also a triangle with a down perpendicular signal and an up triangle signal of a system. Bistable symbols. Figure 11 shows the various conventions that used to indicate the bistable operation. Commonly, one circuit will interface with the other circuits, which require the method to allow the reader to follow the one wire signal path to the first drawing to the second drawing. This may be done by the many of the board. It is generally if the line conductor continued will end of the terminal board. This board will be labeled normally. Continuation drawing indicate with the separate drawing that may exist for each of the line. The next drawing is in hand only the terminal board with the matches of the previous number of the rate needs to be found with the continue. In case of the terminal boards that are not used, the conduction should enter the normal and should end with the number usually in a single digit. Although the next drawing number that is the location continuation consider as a coordination will provide within some of the drawing indicate location for the continuing of the second drawing. The continuation point on the second drawing will also reference back to the first drawing and coordinate with the continuation. A block drawing symbology. Not all electronic parts are drawn with level detail depicting the individual resistor, capacitor, nor level of the information always necessary. The simpler the drawings are called with the block diagram. Block diagrams provide the means of representing any type of electronic circuit with the circuit with the simple graphic format. Block diagrams are designed to present flow of the functional information about the circuits and systems, not detailed with the component part on data with the symbols show the figure 12 that is used in the block diagrams. Alright, figure 12 shows example of the block. A basic block is a common description or a circle with a common component description. A block symbol used to represent an amplifier is a triangle on its side pointing right or left. The arrows indicating the direction of the signal shows the arrow with a filled in arrowhead. When blocking diagrams are used, the basic block shown above is figure 12 can be used with almost anything. When the block represents will be written inside the note that the block diagram represented in the chapter electric schemes become the block diagram are commonly found with the complex schematic drawings to help summarize the flow of the functional information. The use of block diagrams is not restricted to electronic circuits. Block diagrams are usually extended for the show of the instrument channel of other complex systems when only the flow of the path and signal is important. Example of a block diagram. Block diagram is basically an easiest understanding of all type of the engineering prints. If they consist of a single block, what they represent as much as little or desired. An example of the block diagram shown in figure 13. The block diagram represents the instrumental channel used to measure the neutron flux, indicated the measured flux generated output signal with the use of the other systems. For example, figure 13, for example, the block diagram shows the BF3 with a preamp and with a pulse amp, the discriminator. These are set points when it moves off to the isol amp in a indicated direction. Single flow from the isolated amp, the pulse from the pulse amplifier discriminator, the pulse shaper, the pulse driver, log pulse integrator, and level amp. Move on to the isol amp, which has two different conventional bistable statuses. Trips on increasing to two delta amps, and also in the from the preamp, you go through a I don't know, voltmeter. Each bottom block represents a single development, a single that used with the display with the meter of the bottom of the system outside of the bonds of the drawing. Notice that all the blocks are equal. Some of them represent multiple functions, while others represent only a simple stage or single bistable circuit and a large component. With the creator with the block diagram decides the content of each block based on the intent of the use of the drawing. Each type of the drawing received with the previous module and always distinct, they're separate. In many cases, the two or more types of drawings will be combined with a single print. This allows allows the necessary information presented with a clear and concise format. Figure 14 provides a simple sample illustration of how the various drawings can be combined. For example, the mechanical symbols are used to represent the process system, valves, and in control with electronic circuits. Electronic single line symbols are used to show the solenoid relays, contacts used in system. Electronic block symbols are used for controllers and summers and IP converters and bistables. Alright, this shows a figure 14 example of a combined drawing of the pipe instrument drawing with electronic single line and an electronic block diagram. So you have your basic steam pressure header moving into a pair contact and non-contacts with the contact that runs into a, I don't know. This is very complicated. It's Figure 15 uses electronic block diagram combined with electronic single line. The drawing represents a portion of the generator protection circuitry in the normal of a nuclear power generation plant. Summary: the most important information chapter summarized below. The chapter covered the common symbols used in representing basic electronic components, electronic diagram, prints, and schematics. The block diagram represents the flow functional information about a circuit, but is not a detailed description of the circuit. The electronic schematic drawing presents the detailed information about a circuit, that each components, and how they are wired into the circuit. Examples. This chapter provided several examples to reinforce the material presented in this module. Example 1: to assist the understanding, reading, and symbols and schematics, answer the following questions concerning the following figure. The answers are examples given on the page of the following. Figure 16, example 1 shows a PNP rectifiers and NPN rectifiers, resistors, diodes, contactors, grounds. These current, it's different. There's so many different electronic drafting symbols. It's really hard to tell. And then these questions, which I might edit out and put in my OneNote. Example 2 shows a delta sided input with 5 DCs going positive or negative through the rectifier, and a diode to a rectifier with also going into a NPMT through to another NPNT on a circuit that loops on this resistor 13 through, and then the PNP resistor from 13 resistor goes to 14, while also the PNP resistor going back to resistant 14, resistor 20 to resistor 20 delta 1 ohm. Resistor 1, 250 ohms through the resistor RL, and battery 24 volt. And this isn't a diode, but it's what is it? It's one of them without a color filled in. Some of the most important information of the chapter is summarized below. The chapter reviewed the material presented with the module through the practice print reading exercises. Page intentionally left blank. Engineering symbol, printing the drawings, module, logic diagrams. And we're about halfway through.